One last example. A purchaser of electronic components buys them in batches of size 10. It's her policy to inspect 3 components randomly from a batch and to accept the batch only if all 3 are non-defective. 65% of the batches are made in Norman, Oklahoma and have only 1 defect. The other 35% of the batches are made in Stillwater, Oklahoma and naturally contain 3 defective components. What proportion of the lots does the purchaser reject? Okay, so let's think about this. First, let's name a random variable x. Okay, and that random variable is going to be the number of defective components in the 3 that are sampled made in Norman. Okay. We're ultimately going to turn this into a conditional probability, but just for now, let's just keep it to look like this. Okay. And so let's just work this out first. So we want to know what's the probability that we pick 0 out of those 3 that are defective. Okay, because we want to accept these if there are no defectives. Okay, so what's the probability that x takes on the value 0? That is, we see no defects out of those 3. Okay, well, we know that this is a hypergeometric problem. We know exactly what this population coming from Norman looks like. Okay, there's 10 in the batch, and we know that 1 of them is defective. Okay, so from that 1 that's defective, we're going to pick none of those. Okay, that must mean in our sample of 3, we're going to pick from the 9 that are not defective. Okay, and in the denominator, just how many ways are there to pick 3 from 10? Okay, as that turns out, the probability here is 0.7. Okay, so if you work this out, the probability that we get no defective units from those that were made in Norman, the probability is 0.7. Okay, now let's name a different random variable. That's going to be y, and that's the number of defective components in 3. Okay, we're still sampling 3, and they were made in Stillwater. Okay, so what's the probability that y equals 3? Pardon me, y equals none. None in those 3 are defective. Okay, well, we know in Stillwater the number of defective units out of those 10 were a little higher than they were from the ones made in Norman. As it turns out, 3 of the population of 10 were defective. Okay, so we're going to pick none of those 3. That must mean that we're going to be picking all 3 in our sample from the ones that aren't defective, those 7 that aren't defective. Okay, so what's the total number of ways to pick 3 out of 10? That goes in the denominator. Okay, and if you work this out, that probability is 0.2917. Okay, so now we know if we pick those 3 components at random from a batch made in Norman, we know what the probability of having no defective units in those 3 would be. And if we picked those 3 from a batch that's made in Stillwater, we know the probability that we would have no defects. Okay, that's 0.2917. But we're mixing together the ones made in Norman and the ones made in Stillwater. We know that these are made, 65% of them are made over here in Norman, and we know that 35% of them are made over here in Stillwater. And we're mixing all those together and picking a batch at random. Okay? So what's the probability in general that we get no defects from the sample that we pull from a batch? Okay? That is the probability that we get no defects given that it was made in Norman, okay, times the probability that it was made in Norman. Okay? These are not independent of each other. Remember, back to probability rules, if we want this probability A, that's the probability of A given B1 times the probability of B1, plus the probability of A given B2 times the probability of B2. That is the probability of no defects given that it was made in Stillwater times the probability of pulling that batch from the ones made in still water in the first place. OK, we have all this. As it turns out, this probability right here is this one, the probability of no defects given Norman. OK, we didn't call it a conditional probability originally, but that's what it is. And this right here, that's the probability of no defects given that it came from still water. And we know 65% come from Norman, 35% come from still water. OK, so this is 0.7 times 0.65. 65 come from Norman, plus the probability of no defects given still water, 0.2917, times the probability that it came from still water. And there are 35% of batches that come from still water. Okay? This is just arithmetic, very straightforward. As it turns out, this probability is 0.5571. Okay? So the probability that we pull a batch and pull a sample of size 3 from that batch, the probability that we get no defects in that sample of size 3 is 0.5571. Okay? 55% of the time, whenever we pull a sample from a batch of 10, a sample of size 3 from a batch of 10, we're going to see no defects.